SZABIST Karachi has always encouraged its students to seek knowledge beyond the constraints of the university walls, and this conference is a testament to that belief. Today, we stand here at this conference where esteemed guests and speakers have joined us today to present their knowledge and give the aspiring young scientists the opportunity to learn from the experts and the learned. Ladies and gentlemen, with that, I would like to introduce our Dean Faculty of Life Sciences, SZABIST, Professor Dr. Kashif Ali, to you all. Dr. Kashif Ali got his bachelor's and master's degrees from University of Karachi, Pakistan, in the field of biotechnology. During his master's, he worked on a research project based on tissue culture and molecular studies on ornamental plants and other plants. It also involved micropropagation of crotons, anthurium, etc., and PCB-based molecular techniques like RAPD along with SDS-PAGE. In 2006, he started working as Junior Research Fellow at HEJ, Research Institute for Chemistry, where he worked on the in vitro propagation of different ornamental and fruit plants. During this tenure as a junior researcher at HEJ, he published 4 research articles related to the micropropagation of ornamental plants. In 2007, he got overseas scholarship offered by Higher Education Commission of Pakistan for the PhD studies at the Natural Product Laboratory, Leiden University in the Netherlands. He worked on a project named Genomic Research Assisted Breeding for Sustainable Production of Quality Grape and Wine, involving NMR-based metabiomics for grape and wine. After he finished his PhD and went to Kaiji, Germany on Marie Curie's secondment FP7 program. Later he joined Leiden University as a postdoc where his work was on marine metabiomics. Since January 2013, he has joined SZABIST as an assistant professor at Biosciences Department, and today he is the Dean Faculty of Life Sciences at SZABIST. With that, I now request Professor Dr. Kashif Ali to come towards the podium and share a few words.
Assalamu alaikum. Honorable Chief Guest, Professor Dr. Iqbal Chaudhary, Madam Shalaz Wazir President SZABIST, Dr. Mu'atti, Vice President in Emirates, Dr. Eel, Dean Faculty of Life Sciences, Salim Habib University, our esteemed guest, Professor Dr. Shozaib from University College London, and my dear faculty members and students. Assalamu alaikum and good morning to everyone. This is actually the first international conference of life sciences. Before I highlight the objectives of this particular event, I would like to highlight a few things that actually my learning throughout my career, and the most important thing that I have observed, that inspiration is something that actually creates and makes a person, particularly if you have a right inspiration. And if I talk about myself, actually, I got my inspiration from a very similar event that I have actually attended 17 years back. You have heard in my very technical introduction that I have done my master's research at HEJ Institute of Chemistry. And 17 years back, probably in the year of 2005 and 2006, there was a very huge event that we used to call International Symposium on Natural Product Chemistry, where Nobel laureate Sir Richard Ernst actually visited Pakistan. And researchers like me got a chance to have an interaction with him, to listen to him. And this is actually the day or the point where I decided I should pursue my research in the field of NMR. Later on, I got a chance to listen to Dr. Rahman, Dr. Iqbal Chaudhary. He's sitting right here. I have attended their lectures on NMR. These are the inspirations that that makes me to pursue my research interest in the field of NMR metabolomics. And this is what I would like to express towards my students as well, that these kind of events actually give you a chance to get inspired from the true champions in the field of science particularly. And inshallah, in the course of this conference for the next today and tomorrow, you will get a chance to listen the real experts, not only in the field of biotechnology, but very multidisciplinary expertise that we have lined up for you. We have also arranged a very informative and very important session regarding public health, which is going to happen tomorrow morning. And excellent lineup we have for discuss and talk about the issues related to public health. So yes, this conference will definitely work or provide a platform to all of my young researchers and my faculty to interact with the people, to develop collaborations, to learn from different experts in the field. So with that, on behalf of the organizing committee and the Department of Biosciences and Department of Public Health, I would like to extend a very warm welcome to all the invited speakers, the students and the faculty, and I hope you have a wonderful learning during this conference. Thank you so much.
Thank you, Dr. Kashif, for sharing those words. I would now like to have the honor of introducing the Vice President Academics, SZABIST, Professor Dr. Altaf Muqati. Professor Dr. Altaf Muqati obtained his BE degree in Electronic Engineering from NED University in 1981. The Ministry of Science and Technology had awarded him a graduate scholarship in 1987. He joined Boston University, USA, and completed his MS degree and his PhD coursework in 1989 in the field of computer engineering. Later, he completed his PhD research work from Hamdard University, Pakistan in 2007. His dissertation on improved techniques to obtain fault-tolerant semiconductor memories based on error control coding was from University of Southampton, UK, and Nanyang Technological University, Singapore. He has received Best Teacher and Best Researcher awards many times. The Higher Education Commission of Pakistan has also awarded him Best University Teacher Award in 2010. He worked for 17 years at SUPARCO, which is the National Space Agency of Pakistan, and has worked on various national level projects as well. In 2013, he joined SZABIST initially as the Dean of Computing and Engineering Sciences, and in 2015, he was promoted to the position of Vice President Academics at SZABIST. Dr. Muqati has produced several research articles for the ISI indexed research journals and international conferences. He has also authored 4 books. One of his books on fault diagnosis and testing of digital circuits, published by Higher Education Commission Pakistan, is well recognized and is also included in the MS syllabus for computer engineering program. He has also been a member of HEC National Curriculum Review Committee of BSIT, MSIT, BE, and MS Computer Engineering programs. He is an expert and convener of Pakistan Engineering Council. Attendees, with all that being said, I would now like to invite our Vice President Academics, Professor Dr. Al to please head towards the podium and share a few words.
Bismillahirrahmanirrahim. Thank you for this extensive introduction. Madam President Shahnaz Wazir Ali, respected Chair of the Conference, Dean Faculty of Life Sciences, Dr. Kashif Ali, respected Chief Guest, Professor Dr. Mohammed Iqbal Chaudhary, all our valuable national and international speakers, and most importantly, the students. A very good morning. I am very pleased to speak in the inaugural session of this conference, which was much awaited. Unfortunately, due to pandemic, all such activities could not take place during the last 2 years physically. However, we conducted some of the conferences virtually. As we all know, during the last 2 years, the most negative word was positive. So still the pandemic is not over. It is there in some parts of the world, including China. The concept of work from home has emerged the world over. Several multinational companies have moved one step ahead and have introduced agile working, which means work from anywhere, anytime. In all such changing environments, SZABIST was able to shift its activities online quite successfully. Not only we conducted our regular activities, such as taking classes online, but we also conducted guest speeches and some conferences virtually to engage our students. I am happy to see the entire 2-day program comprising a keynote speech followed by several plenary lectures and panel discussions. Most of the plenary lectures have to be given by international speakers virtually. I hope that the panel discussion on challenges and opportunities for life sciences graduates will benefit our students. Tomorrow there will be a scientific session in which the students will have an opportunity to speak about their research work. I am extremely thankful to all national and international speakers from various countries and respected panelists from leading institutions such as Dow University of Health Sciences, PCSIR, Mission Pharmaceuticals, Karachi, and the National Academy of Young Scientists. Ladies and gentlemen, let me briefly mention you about SZABIST. It has 5 campuses. Karachi campus is the mother campus. The other campuses are in Islamabad, Larkana, Hyderabad, and Dubai. We are the first and only Pakistani university running its offshore campus in the Dubai International Academic City since 2003, where we are competing with almost 50 other international universities from England, Australia, USA, and India. I am also pleased to mention that from this year, we are opening our beautiful campus in the city of Garo. All the infrastructure is ready to be functional. It is the largest campus in the private sector in the province of Sindh. Karachi campus has more than 8,000 students in its 41 programs from undergraduate to PhD degrees. All our academic programs are fully accredited by the respective regulatory bodies. Ladies and gentlemen, while the new normal has changed the working dynamics, yet another challenge is in front of us, which is going to change all the working methodologies. Do you know what that is? That is the rapid growth in the area of artificial intelligence. AI is very rapidly finding its place in all walks of life. It is going to influence the discipline of life sciences. AI is catching up with the life sciences sector and big pharma, mainly biomedicine and healthcare. AI is improving patient and clinical trials data collection for drug development and repurposing. Mobile technologies associated to AI have also been used to improve patients' lives. Applying AI to big data in life sciences can help companies reshape business models, streamline biopharma manufacturing, and enhance everything from cognitive molecule research and clinical trial data flow to self-healing supply chain applications and product intelligence. In the end, I must thank again to all the participants and congratulate the entire Faculty of Life Sciences for organizing this mega event. Thank you very much.
Thank you, Mr. Mukati. Ladies and gentlemen, I now have the honor of introducing President of SZABIST, Ms. Shahnaz Wazir Ali. Ms. Shahnaz Wazir Ali was the Executive Director of Pakistan Center for Philanthropy, PCP, in Islamabad, Pakistan, before becoming a member of the National Assembly of Pakistan on a reserved seat for women. She is currently the President of Shaheed Zulfikar Ali Bhutto Institute of Science and Technology. Ms. Shahnaz was awarded the Sitara Imtiaz in 2016 for her services to education. She has an illustrious career as an educationist, development policy specialist, a member of the Pakistan People's Party, twice elected to National Assembly of Pakistan, special assistant to the Prime Minister on social sector, and a well-known women's rights activist. She served as a senior education specialist with the World Bank, held the position of Minister of State for Education, Government of Pakistan, and is on the board of member of prestigious national and international organizations, trust, advisory councils, educational boards, and universities, including SZABIST, IBA, LEAD, and SPDC. Ms. Shahnaz Wazir Ali has represented Pakistan at international conferences and as a highly valued speaker for national seminars, forums, conferences on education, health, women development, population, and poverty alleviation. She has been a champion of numerous social causes such as education for all, women's rights, and polio eradication in Pakistan. Currently, she is the provincial coordinator for the government of Sindh for all primary health care programs. Madam President, I request you to please head towards the podium and grace the audience with a few words of wisdom and encouragement. Bismillahirrahmanirrahim. Our very honorable chief guest, Dr. Iqbal Chaudhary, who is the director of Iccbs. Our Vice President Academics, Dr. Altaf Mukati. Our guests, special speakers, Dr. Akil, Dean Life Sciences from Salim Habib University, and Dr. Shahzeb Heather from the School of Pharmacy, University College London. Very, very especially to our Dean, Life Sciences and Public Health, Dr. Kashif Ali, who has organized, along with his remarkable team, this first international conference on life sciences. And I want to say a very special word of thanks to you, Dr. Kashif Ali, for organizing a conference at this time where it is almost post-COVID, and universities and students and faculty are all returning to a normal life. So I want to thank you and each and every member of your team, Dr. Samira Rizvi, Dr. Hamad Kayani, Dr. Bilal Siddiqui, and everyone else who has worked. And a very, very special welcome to my students from the life sciences faculty, the other faculty members. I think this is for us a very special occasion, because each one of us, our lives, our families' lives, our work, our studies have been affected by a major public health issue, which is the pandemic. This virus, this dangerous, this silent virus that nobody can see or feel or touch, has affected the globe in a way that no other emergency of health over centuries has affected people. The last time civilization was affected on a fairly large global scale was the plague.
There have been epidemics of cholera. There have been epidemics of other diseases. But the way the coronavirus, typically as it is known, coronavirus and the Omicron virus, the way they have affected our lives has made everyone aware of the fact that we really need to understand the world of science around us. And we really need to understand how we, in our lives, are impacted by medical sciences, by the vaccine, which has saved lives, by the fact that perhaps our public health systems weren't strong enough to deter this pandemic, so that lots of lives could have been saved. So today we sit in a very different environment. This environment is a work environment where the virus has determined whether we come to college, schools, universities, and classrooms, or whether we stay at home. This invisible, dangerous virus has determined whether you go to your workplaces or you stay at home. It has determined whether you go and travel anywhere out of the country or you stay put in your home. So the way we operate, our life behaviors have changed. Our thought processes have changed. All of this is connected with this world of life sciences, with the world of medicine, with the world of vaccines, with the world of pandemics. In SZABIST here, our life sciences department and in particular our faculty and our students are really exceptional, because there are few universities in Pakistan, I think, that have the good fortune of being situated in a time span where life sciences has suddenly exploded into probably one of the most prominent sciences. For decades and decades in Pakistan, our students used to study engineering or law or medicine, and you heard a lot about the remarkable profile of our Vice President Academics, Dr. Mukarti, in the field of engineering and sciences, and the remarkable journey he has had. You will be hearing about our chief guest, and the list of his achievements is remarkable. But today, more and more people are talking about health, public health, life sciences. And this is for us a very important occasion that we've been able to organize a conference, which is an international conference. There are speakers that will be addressing our audience from Nepal, from the UK, from Burkina Faso, from Iran, from Turkey, from various other institutions within Pakistan, from the National Academy of Health, from Dow University, from labs like PSCIR, from various pharmaceutical companies. There will be specialists in population who will be speaking to our students tomorrow, I believe. On your program, you have outstanding specialists like Dr. Mehtab Karim, who is a demographer, renowned demographer, Dr. Farid Mudat, who is also a renowned population specialist and an expert, and several other people. So to our students in life sciences, I would say you have this at your doorstep, this wonderful opportunity to listen to experts, specialists, people who have spent their lifetimes engaged in research and study, and in broadening the knowledge base for everyone, not only just life science students. Today, everybody talks about corona, and we all think we're half specialists in the corona pandemic, because you've had to have your vaccinations, you've got to be careful, you've got to change your lifestyles. Everything is affected by what happens in the field of biosciences and medical sciences. So I'm very, very pleased to see that we've had this opportunity to bring together a virtual audience as well as an in-person audience. Virtual speakers as well as in-person speakers. And I'm very pleased on behalf of SZABIST to welcome you all this morning to the inaugural session, and I hope that you will attend all the sessions with the same level of interest. Thank you once again to the Department of Life Sciences and to Dr. Kashif Ali for organizing this and giving us this wonderful opportunity to learn more. Thank you.
Thank you, Madam President, for sharing that insight with all of us. Now, my fellow students and respected guests, we are joined today by the Director of Iccbs and Coordinator General, COMSTEC, Professor Dr. Mohammed Iqbal Chaudhary, as the chief guest for today. Let us begin by first introducing him. Professor Dr. Mohammed Iqbal Chaudhary is a distinguished National Meritorious Professor, Director at the International Center of Chemical and Biological Sciences, and Coordinator General, COMSTEC. Recently, he has received the most prestigious Mustafa Peace Be Upon Him Award in recognition of his services in bioorganic and natural product chemistry. He has also won several other national awards such as Hilal Imtiaz, Sitara Imtiaz, and Tamgha Imtiaz by the President of Pakistan. He received the prestigious title of Distinguished National Professor from the Higher Education Commission in 2004 and Meritorious Professor by the University of Karachi in 2013. He has written and edited 90 books. He is also the author of over 1,226 research papers and chapters in the top international science journals of the West, as well as 64 US patents. The cumulative impact factor of his publication is over 2,550. He has been among the most cited scientists of Pakistan in the last 5 years. He has served as a visiting faculty in many prestigious universities of the world, including Cornell University, Purdue University, Pennsylvania State University, Scripps Institution of Oceanography, the University of Rhode Island, and various top universities in the UK, China, Saudi Arabia, Malaysia, Kazakhstan, and Iran. With that, please put your hands together as I invite Professor Dr. Mohammed Iqbal Chaudhary to the podium to share a few words.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning. I'd like to begin by conveying my felicitation to Madam President, Ms. Shahnaz Wazir Ali, Vice President Dr. Altaf Mukati, Organizer Dr. Kashif, and the wonderful team of SZABIST for putting together an excellent program. So looking into the program, and I really find there are lots of very, very interesting lectures, and this really make this event a very important one. Now, Dr. Shahnaz mentioned about how this pandemic has affected our life. The fact is, this is also the only occasion in human history where science in general and life sciences in particular has responded to human need in the most profound and most effective way. You see, when the first genome was published on January 10th, in December, we were already developed vaccines, about 200 different vaccines were in different development stages. So think of it, the development which took place during this pandemic is completely unprecedented. Science has been the savior of humanity during this pandemic, and that has created a very strong constituency of science. And this is the reason why it is extremely important that we use this occasion, seize the opportunity, and tell people that science is important and we need to invest into science, both in terms of capacity building and also infrastructure. Now, what I would do is to give you a glimpses of 2-3 things, because as a keynote speaker, I need to set the stage. Though I feel that both speakers have already presented the key aspect of why life science is important. I'm going to talk about the recent trend in life sciences. I'll give you just a brief synopsis because I cannot claim to be a life science expert. I'm a chemist by training. I'll give you a few examples of our work at the interface of chemistry and biology. And of course, right at the end, I'll give you what life science capacity exists within the country which you can benefit. Now, if you all understand that life science has addressed many of the humanity's most enduring problems, from agriculture productivity to climate health nexus, from infections to longevity, a whole range of different things which life science has addressed, and that has been the cornerstone of human endeavors in terms of scientific discoveries. It helps us to understand the cycle of existence, The very intricate balance which make us living is an extremely complex one, which is so difficult to understand, and life science has helped us to understand our existence at the molecular level, as well as, our degeneration, our illnesses, our health. Everything is now defined at the level of molecule, and that is the reason why I become relevant, because I'm a chemist, and organic chemists become more relevant with biology when everything is translated into small, tiny little molecules. And life science, I was thinking what I can contribute to tell you about life sciences. And that I thought that I can tell you that these are three different eras which life science has actually gone through. First era, from Plato to Mendel, is the biology of systematics, I mean, you can see, observe morphological changes, and then you become, we have developed taxonomy, anatomy, physiology, and as the technology progressed, we went into the world of microbiology and evolution. This was the first era which was largely based on observation, visibility, and our capacity to see organisms as they exist. Now, at some point of time, about 150 years ago, when chemistry merged with biology, right at the interface, new disciplines start arising. Biochemistry was the first one, the chemistry of biological systems, then chemical biology, genetic engineering, biotechnology, molecular biology, and molecular medicine emerged in last 150 years. But this is the most exciting time when biology has moved out of the other scientific basic discipline and merged with technology. And that technological advances has led to some of the most phenomenal discoveries we have ever thought of. Gene editing by CRISPR-Cas, precision medicine, 3D printing, brain-computer interface. Recently, I had a very profound discussion with one scientist who was trying to teach secondary culture of human neurons. Human neurons have their own brain. Each neuron has its own brain, and you can teach the neurons. So in future computers, not far away, and Dr. Altaf Muqaddi would certainly appreciate that, you would not really need any electronics, but the primary cell culture of neurons will process everything else. So what you would do, you would have a Petri plate or a sheet of neurons, and you give the command, and neurons would be able to process these complex algorithms much better than electronics. So this is the kind of a brain-computer interface which is emerging. And of course, regenerative medicine, you can build a whole human being. Theoretically, it is possible to print any organ theoretically, though it is a bit far away, because complexity of human organs are much more than what we have today, but it is, of course, possible in terms of developing that. And now, today, life science is a confluence of many disciplines. And very interestingly, more papers in life sciences are published not by biologists, but by other people, including me as a chemist. So you will find that 70% of the research papers in life sciences are published by people who have never been trained as life scientists. And so many Nobel Prizes, many of them are physicists or chemists, not the biologists. It not means that biologists have not really got Nobel Prizes. In fact, many of the prizes such as development of MRI was given to a biologist. So its cross-disciplinary recognition is an extremely interesting one. So from molecular mechanism of circadian cycle, how we sleep, how it affects our biological system, 2017 Nobel Prize. And then in 2019, how cells sense and adapt to oxygen availability. And then in 2018, the inhibition of negative immune system, which eventually can be helped, can be used as an approach to control the cancer, was a result of the Nobel Prize which was given. Discovery of hepatitis C virus was 2020, and only last year, this phenomenal discovery of temperature and touch, the discovery of molecular mechanism of touching and temperature sensors. And most recently, I think I would say the next Nobel Prizes among next years would be theory of memory. How memory is stored is going to be the next frontiers in life sciences. Now, what are the greatest breakthroughs in life sciences? See, this is the chronology of how things start developing. In 1800, inheritance was evolution. In the first era of biological sciences, life sciences was adopted on the basis of morphological and evolutionary changes. Then in 1928, antibiotics, and these are enabling technologies. I would not really call them basic fundamental discoveries, but more of an enabling technologies which eventually led to technologies such as PCR and gene therapy. And eventually, at the end, this amazing technique developed CRISPR-Cas. This is the ultimate of gene technologies. You see, this whole dream of gene therapy has now become a reality today, that you, in a living system, in a fully integrated living organism, can make changes by using this amazing way of editing the genes by using CRISPR. And these gene therapies, by using CRISPR, has been so phenomenally successful that whole cycle of GMOs, you know, we often used to think that GMOs are really bad. The fact is, you don't really need to use any external gene. You can modify, modulate, mediate, and change any gene within the living cells without affecting anything else. And that is the most important revolution which actually took place in case of life sciences in recent years. Discovery of biologicals, you know, messenger RNA. Think of it, you know, vaccine used to take about 10 to 15 years. We do not really have any successful vaccine for HIV. Vaccines were developed for COVID-19 within 3 months. In March 2020, the first vaccines were tried on primates. So this kind of a development took place, and now very recently a new vaccine has been developed for malaria, a major killer of humanity. So biological, this is the era of biologicals, where literally many of these development fundamental basic discoveries in therapeutics are in the area of biologicals. And technologies, you know, these technologies have actually revolutionized the entire biomedical sciences and medical sciences. They held advances from imaging. Now, imaging, not only MRI, but also imaging of the brain for thought, for memory, for understanding the biological process are extremely interesting frontiers in development which actually took place. And then artificial intelligence and machine learning, which Dr. McCarthy has mentioned in a most eloquent way. This is the new frontiers with machine and human body are actually working together to augment some of the most enduring limitation of human bodies, from speech to distance. And there is every possibility that new generation of Homo sapiens emerge out of these technological development. 3D printing, so it's theoretically possible that you can translate this 3D printing, a biological version of it, into bioprinting. And that bioprinting already is routinely used for the development of cartilage, for the development of skin for burns, and a whole range of different tissues which are actually developed, and the whole organ is not far away. Perhaps in a decade or so, people would be able to develop the entire organ by using 3D printing. And biotechnology is the most important frontiers out of the life sciences. Biotechnology is the one in which one can really go into literally everything from agriculture to environment, from industries to health. Biotechnology is contributing in the development of human society in a very profound manner. Now, you scholars, you have a tremendous opportunity of moving forward in life sciences. You have tremendous opportunity of becoming professionals in healthcare. You can go into biomedical and pharmaceuticals. You can even go into banking and financial system with your profound knowledge of life sciences. You can have a strong impact on biological system, because about 45% investment in today's technologies are largely in life science technology. You can go into education, you can go into research, you can become entrepreneur, you can work for the public sector. Whole range of topics are currently available for you. These are your frontiers, these are your topics, these are your future in which you can contribute in a major way. Now, what I will do, I'll just give you 2 examples of a recent work, and I've selected very simple examples, not because I underestimate your capacity to understand, but just to tell you that there is a possibility of doing science in a very simple and elegant manner without using much of technological advancement. And for that, I would like to take the opportunity of telling you that our work at the interface of chemistry and biology for drug discovery and development has been very, very successful. Why we have decided to do that? Because of a very simple fact that in order to develop one single drug, you need to have 1.2 billion to 1.8 billion US dollars. This is the kind of investment you need. You need to have 8 to 12 years, you need to have 1,000 scientists working together, and then literally for thousands of different compounds before you get one drug. This is the kind of input you need to have for the development of drug. This is the reason why not a single drug from any developing countries has emerged so far, not a single drug. And that is the reason where we need to find out of the box thinking. We need to go for innovative approaches. Drug discovery today is in crisis because for many diseases there are no drugs available. What we have done, that we have actually used biotechnology, and this is the interface of chemistry and biology. And what we have done was a result of a very interesting discussion. I was traveling with Professor Dr Rahman in Turkey, and he said, why don't we just work on old drugs? Old drugs, there's so much of pharmacological data available, there's so much of pharmacokinetics data available. Why don't we use this already existing knowledge and convert them into a new drug? So we embarked on a very interesting new field, and we start working in old drugs and start modifying the structures to fit into a new drug target. This is called drug repurposing, and what we have done was that we used drugs, modify their structures, and try to find new indication of an old drug. And that was actually mixed with the new opportunity, because patent cleft and generic medicine have actually provided us opportunity to have access to large number of drugs without any IPR violation. We modified the structure by using biotransformation. So we use enzymes, we use fungi, we use bacteria, we even use animal and plant cells. And by doing that, we were able to find new pharmacophores from the existing drugs. I'll give you an example of what we were able to achieve. This is an extremely simple science, a very, very simple science. It is a science of largely porcelain pans. You need to have large flowers. You, instead of having library of chemicals, you have library of microorganisms, and you use these microorganisms to transform the structure. Now, if you look into this very simple diagram, you'll find that there is one hydroxy group introduced at C11 position by using a rhizopus of fungi. Now, if you want to do this structure, if you want to do this kind of a transformation by using chemistry, it's really difficult. It's very, very difficult because you need to have a whole range of different protection and deprotection. This fungi is capable of introducing this hydroxy group in the structure in a very particular orientation called alpha, and that makes this compound substantially different from this one. So using an old drug, a new drug was prepared because the basic pharmacophoric skeleton remained the same, new functionality was given, and for that we actually we coined a new word called drug redressing, which is now commonly used called drug redressing. Redressing the drug molecules by using different functionality. Extremely eco-friendly. You don't need to have large number of catalysts or any toxic solvent. You do that at ambient temperature and you get almost quantitative yield by using this methodology. Now I'll show you the example of how the entire thing is done. So we have a whole library of microorganisms, about 200 of them in one of our laboratories. We grow them in different medias, we inoculate them with the compounds, and then we extract them. And by using this technology, we have novel structures, we go for all kind of a characterization and biological assays. Now, for what purpose we can use it? I'll give you one example of that particular project. Breast cancer is extremely prevalent in the world. It is unfortunately very, very prevalent in Pakistan. Pakistan is one of the countries with highest rate of breast cancer mortality and morbidity, with 90,000 cases reported annually and about 40,000 unfortunate deaths. And unfortunately, majority of these breast cancer, especially in Pakistan, almost 3/4 of them, almost 3/4 of it is estrogen receptor positive breast cancer. Now, estrogen is an extremely important hormone. You know, estrogen is a hormone which helps in multiplication of cancer cells, and therefore deprivation of estrogen, somehow you need to deprivate or you need to deplete the concentration of estrogen, is extremely important approach for the treatment of breast cancer. This is a very valid target, and for that purpose we need to work on aromatase, because aromatase is a critically important enzyme which play a role in the synthesis of estrogen. Aromatase inhibition means that you would be able to control the production of estrogen in the body. So this is the approach which we have used. This is the kind of a reaction aromatase catalyzes. Aromatase is an enzyme which is present in many peripheral tissues, including adipocytes and others. And this aromatase catalyzes aromatization of ring A. Now, aromatase is capable of converting many of these testosterone and androstenedione into estrogens. And these estrogens are the one which is required for cancer progression. If we can inhibit aromatase, we'll be able to inhibit the production of estrogen, and by doing that, we'll be able to inhibit the growth of the cancer. This is the basic hypothesis, This is a very valid hypothesis because it is one of the most important target. This is the structure of aromatase, and it has two different sites. So aromatase can be inhibited by using peripheral or active site approach. And these are some of the drugs available. So drugs, non-steroidal drugs available, letrozoles or anastrozole, which inhibit aromatase, but at the same time, aromatase can also be inhibited by using steroidal inhibitors. We opted to go for a steroidal inhibitor because of a very simple reason. Steroids are the one which mimic the substrate. And if you can mimic the substrate, you would have reversible inhibition of the aromatase. And that is what we have decided to do. We developed many aromatase inhibitors of the steroidal nature, and for that we have developed this approach. We have used this approach, which I mentioned, biocatalysis. So this is druggable site 2 and druggable site 2 and druggable site 1, and these are the two sites on which aromatase can be inhibited. Now, where to get the aromatase? The reason why I'm presenting this, because these are life science students and you need to know where to get aromatase. Aromatase is not commercially available. You know, you can't really buy it. Even few units of it, if you try to get it from some science laboratory, they'll probably charge you $5,000. So what we have done was that we have used our own recombinant laboratory. By using molecular biology, we were able to express aromatase in very large quantities. So now, today we are among the largest suppliers of aromatase enzyme, pure human aromatase enzyme, which we express and produce in our own laboratory. Now with this, we looked into chemistry, because you see, our strength is chemistry. We want you to know which molecules can be converted into drugs. We looked into it and we found that many of these drug molecules with some level of unsaturation in ring A are absolutely essential, critically important in order to have aromatization. You cannot really convert a fully saturated ring A into aromatic ring. So we looked into it and then we decided to try all of them, all of these drugs, and convert them into new aromatase inhibitors. I'll give you an example of it. So Xmastine, which is primarily a molecule inactivate aromatase enzyme, we decided to convert that into a new class of aromatase inhibitors. Now, my slide is just behind you. Okay, so you see, what we have done is an extremely simple science. I mean, you can go into chemistry laboratory and can burn the whole laboratory, can have all kind of toxics, catalysts, solvents, and whole range of different things, fumes and smokes and everything. Absolutely neat science, which we have opted. We decided to use this microorganism, fungi and bacteria. We converted this molecule into a whole range of different analogs. And if you look into this analog, you find this selectively reduced into alpha hydroxy. You found that selectively reduced into beta hydroxy. You found that this is a position where an hydroxy is introduced at a beta position, and you also find that this double bond between 3 and 4 and 5 is reduced in a very interesting manner. This molecule is several-fold more active than the drug, several-fold more active. This is already in phase 2 clinical trial. Now, I'll show you another molecule which we have, and this is based on a very logical approach of, instead of using random chemical space, why don't we use drugs which already exist? So by doing that, we were able to identify the places where this molecule interact. Test electron is another very interesting drug, and what we have done for test lock was a molecule which was developed in 1968 in Germany. We took that drug and converted that into in 12 days by using this fungi into molecules which were several-fold more active. It is even more active, and you see this is nanomolar quantity. So by using this approach, we were able to develop new pharmacophores based on existing pharmacophores with lots of pharmacokinetics and toxicology data available. We don't need to do many of these earlier studies again, maybe perhaps a shorter version of it, and we were able to create new molecular entities. Of course, we have done lots of other studies also. I'll just show you one more slide of this, and you see that some of these molecules were several-fold more active than the standard drug, which is currently used for 5-year therapy after post-surgical removal of breast. Okay, so this is the kind of work which we have done. I'll just give you one more example of a very simple science, and that is the development of nutraceutical. Now, as you know that these are drugs, you know, what I have presented to you are drugs, and for that, you need to have very extensive studies for kind of different approvals and different things. But nutraceutical is a very easy way to crack, and for that we have actually selected Parkinson's disease, which is unfortunately on rise in our country and globally. And what we have done was that we have developed an animal model which mimic these symptoms from, you know, tremor to postural and speech issues. This is actually located at substantia nigra, where dopamine producing neurons are present, and there is a number of decline in the number of these dopamine producing neurons, which eventually lead to Parkinson's disease. So what we have done was that very simple science. We looked into literature and we said what people have discovered already which help in stopping oxidative degeneration of neurons. The one which people have studied for as free radical scavenging, and which one was the dietary origin. Some of them were already studied for Parkinson treatment also, and we putting them together 100% dietary formulation. 100% dietary formulation by using this model called rotenone-induced PD model, which mimic different levels of Parkinson. There is a scoring of Parkinson which is available. Score 8, this is the pathological group in which we have provided no treatment. As a result, you can see that literally from 32 to 30 died, so there is no self-healing, only a few 6% of them were able to have self-recovery. So we, using these different scoring mechanism, we were able to develop a very successful model. And this is the drug which is used. So, you know, if you go and meet with any Parkinson patient, you would find that they're actually using levodopa or carbidopa. So this is the drug which is a mixture of two different medicines. And this is the one which is used as a ScienceMed. ScienceMed was able to have 23% recovery, 50% recovery, and 22% recovery. Now, this is not the treatment. Let me tell you that this is only management of the symptoms. There is no medicine available for the treatment of Parkinson's so far. Nothing exists, and only what we are trying to do is to manage the symptoms. But what this very simple formulation was able to do is to have an absolutely phenomenal, about 78% to 95% relief in symptoms. So this is a symptomatic treatment, 100% dietary, and we were able to prove that by using this formulation, people can have improved symptoms of Parkinson. So this is the kind of results which we have obtained. Of course, we have done lots of different science. We looked into brain of rat, we looked into the level of dopamine and others. So what we were able to do that we develop a herbal formulation for PD. We used this rat model, and these two models are now in very different phases of development. We already have a US patent for that. It's now patent protected, so it is intellectual property right protected product, and we are in the process of developing the first phase clinical trial. Now, right at the end, I want to give you a glimpses of what exists in our country. We already have an MOU signed, so we are sister institutions, and we had a very good discussion with Madam Shahnaz Wazir-Ali. We planning to work together, and for that we have also developed a mechanism of joint supervision. So I'll give you what we have in some of these sections, because this institution is quite big. We have a stem cell research unit. This is a national stem bank facility, and the equipments which are, of course, the most important are our colleagues who are leading experts in the field of stem cell, and the kind of facilities available are actually provided to you here. So we have excellent cell culture facilities. We have, different kinds of docking and imaging facilities. This is Jamil Rahman Center for Genome Research, and this is one of the finest second-generation genome facility. So we do lots of disease genomics by using these kind of facilities available. And if you have any genome-related project, we would be very happy to help you by giving you access to some of these sequencing devices which are state-of-the-art. We have a separate center which is established only last year, in which we would need your help, because our expertise in this area is not that much artificial intelligence and health sciences. We have a very large computing system, and what we're trying to do is to develop new applications of AI in disease diagnosis and other aspects of it. There is a computational biology unit which is supported by a large cluster computer, and this facility is actually being used to understand the complex network of factors which are responsible of different kinds of diseases in human conditions. Then we have a molecular structure biology. We are capable of producing any protein, almost all proteins, not any protein, in any quantity by using E. coli as well as insect cells. So we have this amazing capacity of producing recombinant proteins. And then by using NMR spectroscopy, nuclear magnetic resonance spectroscopy, to get the structures. Then we have neuroscience unit. This is a fascinating unit because we are capable of taking a single cell from the brain and carry out single cell physiology by using this electrophysiological equipments, and of course there are a number of other facilities available. This is the National Institute of Virology, the only one in the country which is equipped with BSL-3 facilities locally manufactured in Pakistan. So this facility is used for a whole range of different projects during COVID-19 pandemic. And of course we have an imaging facility, so we are the most powerful facility in the country for all kinds of imaging, from animal imaging to human brain imaging, as well as cellular imaging, from AFM to ICM and other microscopic facilities are available, and this is the National Imaging Facility. This is the National Center of Bioequivalent Studies and Clinical Research, and that we use for clinical studies of different kinds. We can carry out phase 1 to phase 3 clinical trials of vaccines as well as small drugs. This is our National Animal Facility. It's called LAFRA, National Facility for Laboratory Animal Research. This is a new facility, and in this we have gene knockout and gene knock-in animals, and as well as training facilities for. So this is the kind of facilities which are available. I've been introduced as a Coordinator General of COMSTEC, so just last 3 slides. These are the opportunities for you to use. This is COMSTEC Fellowship for Virology and Vaccine. You can go anywhere in the OSC world for virology and vaccine technology training. This is COMSTEC Africa program, which is largely focused for African scientists, and they're coming to Pakistan and other OSC countries. This is Africa program. There are a lot of people coming, including some scholars are here. And of course, this COMSTEC is also using our own conduit and mechanism to help Pakistani institution. With this, I would like to acknowledge my colleagues, a wonderful group of people, extremely smart, and they know what they are doing. Very, very smart people, extremely hardworking, and they are the one who conducted lots of these research. Some of this I presented here. And I'd like to thank you for inviting me. It's a pleasure of coming to this institution. This institution has a vision. It is always a pleasure to come and visit this institution. Thank you very much. Thank you. Any question? Yes, please.
Hello. It was very informative. My question is that it is possible to modify microbial enzymes by plant products for different treatments of diseases?
Microbial enzymes?
It is possible to modify microbial enzymes for the treatment of different diseases by plant products.
It's an interesting idea. Never thought about that. Microbial enzymes are actually used for different kinds of treatment as well, but modifying them by using plant product is something new for me.
Thank you so much.
I have a question.
Yes, sir.
First of all, thank you very much for giving this nice speech. As you know that Helicobacter pylori is very common in Pakistan. So have you tried to develop any product to eliminate this?
So Helicobacter pylori, again, one of the most important Nobel Prizes ever given to human being, was the discovery of Helicobacter pylori as the cause of cancer. And Helicobacter pylori, ulcers were thought to be because of acidity, smoking, and others. And it was only when William and one other name in Australia, who were the one who discovered Helicobacter pylori as causative agent for ulcer. So we have a whole range of project, there is 3-hour lecture which I can present on Helicobacter pylori. Helicobacter pylori survive in human gut because of an enzyme called urease. Urease is the one which neutralizes the acidic pH into basic pH and help Helicobacter pylori to colonize human gut, especially stomach. So if we inhibit urease enzyme, Helicobacter pylori is not capable of colonizing it, and we have developed many urease inhibitors. Yes, please.
So it's so wonderful. It was a picture of tomorrow. So being an MBBS doctor, I'm working with the health department. So my one question, the people are suffering from the diseases and they have the failure of organs. So your esteemed institutions are working for the organ cloning or certain production of organs. Could it possibly?
You see, stem cell is the primary edifice of regenerative medicine. Stem cell is used for creating different kinds of functional cells, so-called pluripotent cell into single function cells. And by using that, we were able to have, at the animal stage, we were able to create skin. We were able to have implant for kidneys, and we were able to have implant for cardiac tissues. We will be very happy to show you if you come. But this is only for the animal yet, not the clinical practice.
Assalamu alaikum, sir.
Alaikum salam.
Sir, my question is that we are facing a big global issue, that is pollution, and it also causes global warming. What is your opinion? Like, this global warming is affecting our plant. Does it affecting our plant products which you are using for your medication processes? Like, जिस प्लांट से हम प्रोडक्ट्स कोई कंपाउंड एक्सट्रैक्ट कर रहे हैं, इस ग्लोबल वार्मिंग की वजह से फ्यूचर में भी क्या यही कंपाउंड आपको मिल सकता है या कोई ट्रांजिशन होगी? Is there any chances?
With the disclaimer that I'm not really expert of atmospheric or climatic change, I would say that you're absolutely right. I think global warming is changing everything, including plant products. So these abiotic stresses which would affect plant secondary metabolites also. Yes, ma'am.
A very basic question about Parkinson's. The information that you gave was that you can manage it. You can't cure Parkinson's. But the herbal food dietary type of regime that a person can follow, this is often not advised so clearly to a lot of patients. So is it possible that from your center, some of these advisories can also be made public and issued, which would be non-detrimental? In other words, they would be safe for any Parkinson's patient. I happened to have been in Lahore on the last Eid holidays, in fact, and two people very close to us in the family and a friend are both down with Parkinson's. And I did not see them having any such advice, being given any such advice. So is it not possible for your center to do this as a public health service?
Absolutely. The one which we have developed is also for the management. It's not for the treatment also. But you're absolutely right that these chemicals like levodopa or carbidopa are extremely toxic because they affect the other body part also, because dopamine is required for other functions too. So blocking dopaminergic enzyme is unfortunately affect the entire body too. You're absolutely right that this formulation which we have developed, which is now internationally protected too, can be used for, and I'll be very happy to share this information with public too. This is also in observational trials, so it's available in South City. Yeah. There are 3 neurologists who are actually involved in observational trials.
I have one more question, Dr. Iqbal, which is about stem cell. Is there any place in Pakistan that is, do you think that there's potential in stem cell treatment? Because some time ago, I believe some hospitals in Pakistan tried it. They set up their stem cell treatment centers for certain things, and then it didn't, they had to be shut down. So is stem cell treatment not significantly advanced, and is it available in other countries?
Stem cell regenerative science has advanced, but their clinical applications are only limited to 3 different applications: joint pain, burn, skin burn, and also for this so-called spinal cord injuries. This is the only 3 applications which are clinically allowed. And if people claim for kidney regeneration and all that, at clinical level it is not allowed. And also only recently, a US FDA has approved this cartilage between, the doctor would be able to tell, cartilage which exists between या cardiomyocytes, chondromyocytes, उसका क्या नाम है? Mescaline ये सब कुछ करके नाम है. That is now also allowed. This is the third indication which is allowed by US FDA. For other indications, it is yet to be approved by clinical application, including diabetes. Pancreatic beta islet regeneration is still not approved by clinical trials, but this is already in the pipeline.
Assalamu alaikum. I am Dr. Sikandar from Qaid-e-Azam University, Islamabad. So thank you so much. We are honored to have your lecture and a very good knowledge. My question is rather a comment that what's your comments on future of AI, as the Stephen Hawking was already saying that wisdom should prevail in the applications of AI. And the second is second part of my question is a bit humorous, taking that why the men are more prone to the Parkinson's disease than women.
I think women use their brain much more effectively than men. And it's not really a joke, is absolutely true. Alzheimer and Parkinson are less likely to occur in people who use their brain most effectively. And it's proven without doubt that women use their brain much more effectively than men. As a result of it, men are more prone to Parkinson's disease. AI is new frontiers with lots of dilemmas, problems, and threats. We don't know what will happen.
So my question is, you have mentioned about the exemestanes and its derivatives, which are now in phase 2 clinical trials. So my question is, are there any other products developed by your center that are again in the phase 3 or in the advanced stage that you have developed?
I think the one which we have discovered, there are plenty of other things also, but these are the most prominent one, and I think it's enough to take them to the next phase. So I would not really go and spread ourselves too thin. We'll just focus on these 3 derivatives which I mentioned, and if we are capable of developing them into a drug, that is, I think, worth putting efforts on.
Thank you, sir.
I'm Judge, faculty member of SZABIST. Thank you for your very informative lecture. I want to know, sir, in your research, did you use the whole microbial cell rhizobius for the modification of plant product, or did you use any particular enzyme or product from that microbial source to modify the medicines or drug?
The one which I presented was a whole fungal cell.
Okay, so when you use the whole fungal cell, so is it possible that any harmful change can also occur in the drug which is not desirable?
No, chemical drugs में तो gene नहीं आ सकती. These are chemical drugs which you isolate by using chromatographic techniques, so no gene is mixed with them.
No, I am asking about the modification. Is it possible that any undesirable modification or group can attach to that drug?
You see, microbial transformation provides you lots of novel entities, and this is your selection, which one you would like to select. So you may have the whole library, but eventually you decide to select 1 or 2 of them because they are the ones which are active. So regardless of what kind of changes taking place into the molecular structures, you would have choice of selecting the best one which you wish to use for your own biological activity or bioprospecting.
All right, sir. Thank you.
Thank you. Thank you very much. Thank you. Thank you.
Thank you, Professor Dr. Mohammed Iqbal Chaudhary. That was extremely insightful, helpful, and enlightening for us all. I would now like to request Madam President, Ms. Shahnaz Wazir Ali, and Vice President Academics, Professor Dr. Altaf Mukati, onto the stage to present our chief guest, Professor Dr. Mohammed Iqbal Chaudhary, with a shield.
very, thank you.
Extremely grateful. Thank you. So मैं जा रहा हूँ Chinese scientist I will have a meeting.
मैं सोच रहा था कि टीम पे आपसे एक सवाल पूछूंगा.
सर मैं आज का टीम में आपके पास है. और वैसे आया ना कल आज सुबह पहुँचे. He's leaving tomorrow.
You collaborating with them or something? So we'll have a meeting with you at some point because we've been talking recently. Yes, I know. Presenting the bouquets.
Thank you so much. I'm so grateful. Thank you so much. Just let me know, I'll come over. Thank you so much. Sorry, after the leave, I'll call you. Sure.
Thank you to our chief guest, Professor Dr. Iqbal Chaudhary, Madam President, Ms. Shahnaz Wazir Ali, Vice President Academics, Dr. Altaf Mukati, Dr. Kashif Ali, Dr. Aqil Ahmed, faculty, guest speakers, and students for gracing this occasion with your presence. We will now be taking a short tea break. Students, please remain seated. Faculty and our esteemed guests, please head towards the meeting room for some refreshments. We will reconvene after the tea break. Thank you.